Hello everyone, welcome back to my YouTube channel. Today I want to start giving some evidence for God's existence, and we often hear the claim that there is no evidence whatsoever for God, that it's pie in the sky, totally fabricated, made up. Today I want to give the first argument for God's existence, which is based on evidence from physics, and that argument is called the fine-tuning argument. But before I move on to that, I want to just do a quick recap on the last talk. So in that, I said that under materialism slash atheism, I argued that that worldview is self-defeating and inconsistent, and in fact, it borrows its values from theism, particularly when it comes to morality. The next point is that a deterministic, or that a physical system is by its very nature deterministic at the macro level, the large scale level, and at the quantum level it appears to be random. So basically, if our thoughts are produced by these kind of processes, by chemical reactions and the flow of electricity and so on, it's not going to give you any kind of truth because there is no agency involved. The reactions just happen, and we have no control over them. We cannot control the flow of electricity where there is no external input. The next thing then was I mentioned talking about free will, and again how under a deterministic system there cannot be any free will. How could there possibly be any free will if chemical reactions just happen and we can't control them? So while we might appear to have free will, we couldn't possibly, if you believe in a materialistic worldview. The next thing I said was that materialism cannot explain consciousness, and particularly self-consciousness. How can matter be aware of other things around it and also aware of itself? And how did the universe produce a brain or a mind that is capable of understanding pretty much the entire universe? It makes no sense whatsoever. I also made the claim that atheism slash materialism is not any kind of basis for objective morality. All, let's say, normal human beings do believe in objective morality. They believe, for instance, it is wrong to torture an innocent child. Only psychopaths think otherwise. So, if we believe in objective morality, the question is, where does that sense of morality come from? Those moral obligations, what is the basis for those beliefs? And you got to, it's quite a challenge to explain those things under materialistic, naturalistic worldview. So in that, under that scenario, basically a person would have the same dignity as a rock or a tadpole or a chimpanzee. I mean, the only difference between those different creatures is the level of complexity and the physical arrangement of matter. So that is no basis for dignity of any sort. So I want to move on to the first item then, which is the evidence for God based on the fine-tuning argument. So this one is taken from physics and cosmology. And before I delve into that, I will just ask the question, what is God? And according to St. Anselm, God is the greatest conceivable being. So in that case, if you conceive of God as a particular type of being with particular attributes, if you can conceive of a being which is, let's say, more loving or more merciful, then that being must be God. So in terms of God's attributes, theologians and philosophers will tell you that God is simple in the sense that he's not made of any parts, because if you did have parts, you have then to explain how all those parts came together and where they came from. So God must be made of one single unified substance with no parts. God must be all-knowing, all-powerful, but not capable of logical contradictions. So people ask the question, well, is it possible for God to create a rock so heavy that it can't lift it. It's a logical contradiction. God must be perfectly holy and pure, perfectly just and merciful, and these are the kind of attributes you expect from the greatest conceivable being. So moving on to the argument itself. According to the standard model of particle physics, there are something like 30 different parameters that determine the way that the universe functions. They determine the shape and structure of the universe, how quickly it expands, the way chemical reactions happen. Pretty much every aspect of the way things happen is determined by all these constants. The thing about these constants is that they are random. It appears that the values they're set to particular values, and science cannot explain why they have those particular values. So scientists have tried to come up with different models to explain why they have the values they have, and they have so far failed to do that. Okay, so what is the point of this? The point is that if these constants, these 30 constants, didn't have the values that they do, then life on planet Earth or any planet would not be possible. And the reason for that I will get into shortly. The second point about the values is that they need to be very, very finely tuned. And I will also discuss just how finely tuned those values are. Okay, so here are an example of some of the 30 constants of particle physics. These are probably the most highly tuned constants. So what we're looking at here, the first one here is the ratio of electrons to protons in the universe, the ratio of the number of each, and that is tuned to 1 part in 10 to the 37. Meaning that that is 10 followed by 37 zeros. So if you were to change the very last digit, then life in the universe would not be possible. So that is an incredibly large number. The next one is the ratio of the electromagnetic force to the force of gravity. Again, very highly tuned, 1 in 10 to the power of 40. The expansion rate of the universe has to be finely tuned to 10 to the power of 55. The mass density of the universe, 10 to the 59. And the cosmological constant, 10 to the 120th. Now, to give you an idea of the size of those numbers, physicists or cosmologists estimate that there are 10 to the power of 80 atoms in the entire known universe. So we're talking about hundreds of billions of stars in each galaxy and hundreds of billions of galaxies. So that is an absolutely incredible number of atoms. So when you compare 10 to the power of 80 with 10 to the power of 120, you start to get an idea of just how finely tuned things are. Okay then, so to take one example, the mass density of the universe, which is, as we saw in the previous slide, was 10 to the power of 59, let's say 10 to the power of 60. So what that means, the significance of that is that if you had a string of 60 digits and you changed the very last digit, the least significant digit, then life would not be possible anywhere in the universe. And the reason for that is that if the value were any smaller by that last digit, the universe would keep expanding and become very, very sparse. So everything is going to be spread out very finely, and no matter would clump together, allowing stars to form. So initially after the Big Bang, you had pretty much nothing but hydrogen, maybe a little bit of helium. I'm not even sure if there was helium. I think maybe that was formed in stars. But the very, very precise expansion rate of the universe allowed all the hydrogen to accumulate, to collapse, and under its own gravity to be crushed and to form the different heavy elements like oxygen, nitrogen, potassium, all the different elements that are needed to create life or sustain life. If the value of the mass density of the universe were any larger by 1 digit out of those 60 digits, the universe would basically collapse back on itself into one massive black hole. So we're really talking about a very, very finely tuned knife edge situation where the expansion rate has to be just right for stars to form. And of course, if stars didn't form, we wouldn't have the heavy elements that are needed for life to exist. Okay then. So we're talking about a Goldilocks situation here, which allows stars to form. And stars are the nuclear furnaces, as I said, creating the heavy elements such as oxygen, nitrogen, carbon. Obviously, carbon being a very, very important one for human life. And we are essentially made of stardust. So the stars eventually, not terribly well up on astronomy, but the stars at some point exploded. And all that material was fired out into space, and eventually, after something like 10 billion years, clumped together to form the likes of planets and the various moons and things around planets. So there was a physicist by the name of Hugh Ross who gave an example of the degree of fine tuning that's involved in the total mass of the universe. And what he said was that if the entire mass of the universe, so that's the 100 billion galaxies, if you took the entire mass of the universe and changed it by the weight of a small coin, that is the degree of fine tuning that would prevent life from existing in the universe. So if you took away the mass of a single coin, it means that the stars would never form because everything would just spread out into a very, very thin kind of cloud of gas. If it was heavier by the mass of a coin, then it would just collapse back on itself. So you can get an idea from that just how exquisitely fine-tuned everything is. Now that figure I gave you, the mass density of the universe, is the one which is 10 to the power of 59, but the cosmological constant is much more finely tuned, which is 10 to the power of 120. So the kind of figures involved are just absolutely mind-boggling. So a question that people often ask is, why is the universe so large? And the answer to that is pretty simple. It actually takes that long for stars to form and then to burn out and collapse and then explode, and then to subsequently form planets. And the universe is so large because of the expansion rate. So when given the time multiplied by the expansion rate, that will determine the size of the universe. So the Earth is believed to be about 4.5 billion years old, and it took the universe something like 9 billion years to form the matter required to make planet Earth. So we're talking about an entire age of something like 13.8 billion years. Okay, so when scientists realized that there was an extremely high degree of fine-tuning, a lot of physicists became very uncomfortable with that idea because it smacked of the idea of an engineer behind all these parameters. So they tried to get around that idea by coming up with a multiverse. And in the multiverse, you have something like, or very close to an infinity of different universes. And by random chance, we just happen to be in the universe in which all the parameters are precisely the values that we need for life to exist. Now, the problem with this theory is that there is absolutely no evidence for it. It's pure speculation, pure hypothesis, and there is no possible way we can observe any of these universes. So it can never be tested and never be proved. It's probably just going to sit on a shelf as an interesting artifact of physics. But all the experiments have been done to prove over and over again that Einstein's theory of general relativity is the theory. It's been corroborated so many times, and it goes to prove that the Big Bang, or certainly corroborates the idea that the Big Bang happened 13.8 billion years ago. Okay, the other theory is the oscillating, or one of the other theories is called the oscillating universe, in which there's a Big Bang followed by a big crunch and a Big Bang and a big crunch. So that would give you, in theory, would give you an eternal universe, one which had no beginning. But the problem with that is that it falls foul of the Born-Guth-Vilenkin theorem, which is, as I said in the last video, mathematically proves that any universe which is on average expanding cannot be infinite to the past. In other words, it began at a finite time in the past. And we know from observation that our universe is expanding, and we know in fact that the rate of expansion is accelerating, which is another reason to believe that the Big Crunch will never happen. Okay, so why am I giving people this information? Basically, St. Peter in his epistle said, "Always be prepared to give an answer to everyone who asks you to give the reason for the hope that you have. But do this with gentleness and respect." So the whole reason I'm doing this is to work towards a belief in God and ultimately a belief in Christianity. And that is it for today, folks. So thank you very much for listening, and I'll see you soon. Goodbye.